Hi folks, welcome back to the last video in 11.1, sequences and notation. So as I mentioned in part 3, we're taking a look at just some different kinds of examples to show us really how broad the idea of sequences is, but that the same process will help us with all kinds of sequences. So consider this formula. Ooh, it looks like a lot, right? There's lots of n's everywhere, but I know because I only have n's on the right-hand side and no a sub n's that what I have here is an explicit formula. Okay, that means that I could find the first 6 terms like I'm asking us to do here, or I could ask us to find the 500th term or the millionth term, and that would be fine. Okay. Also, keep in mind that what we're having here is a discrete function. So if we were to imagine these points on a grid, we would not connect them with any sort of line or curve because there's no values for n that are not integer values. Okay, in fact, they actually have to be positive integer. So let's go ahead and determine the first 6 terms of the sequence. Do we start with 1 or 0? This will always tell us. So in this case, I need to start with a sub 0. And all I'm going to do is grab this formula. Everywhere that I see an n, I'm going to replace it with 0. So -1 to the 0, and then times 0 squared. And then 0 plus 1. Okay, so n's get replaced by zeros. We're very careful with our computation here. We get -1 to the 0, which is 1 times 0 over 1. 1 times 0 is 0. 0 divided by 1 is 0. A sub 1. Going to do the same exact thing over here, except everywhere that I have a green 0 highlighted is actually going to be a green 1. So -1 to the 1 times 1 squared over 1 plus 1, right? 1's go everywhere I see an n. So I get -1 times 1 over 2, which is -1/2. All right. If you think you got the hang of it, now is a perfect time to pause the video and go ahead and try and find a sub 2, a sub 3, a sub 4, and a sub 5 on your own. Okay, so a sub 2, I'm replacing all of my n's with 2's. I could do the same thing for a sub 3, except instead of 2's, I want 3's. All right, so 3, 3, 3, 3. And if I work through the arithmetic here, I should get 1 times 4 over 3, which gives us 4/3. Over here, I should get -1 times 9 over 4, which is -9/4. Okay, and let's go ahead and copy and paste these two to find our a sub 4 and our a sub 5. All right, a sub 3. Oh no, I just found that one. A sub 4, 4, 4, 4, and a sub 5, 5, 5, 5. All right, let's get rid of those. All right, we've got all our 4's in place. We've got all our 5's in place. All right, we get 1 times 16 over 5 is 16 over 5. And then negative 1 times 25 over 6 is negative 25 over 6. All right, now, just to practice some notation here, if I wanted to write out the sequence, I would put them all in a squiggly bracket, 0, negative 1/2, 4/3, negative 9 over 4, 16 over 5, negative 25 over 6, and the ... shows me that this is an infinite sequence. Okay. Now, in fact, this also happens to be another kind of sequence where the signs go from positive to negative, positive to negative, positive to negative, all right? So when you see these kinds of sequences where the signs change or they alternate, we call them alternating sequences. Surprise, surprise. Okay, but the alternating really refers to the sign being positive, negative, negative. Okay. All right. So good practice and just plugging in the formula. Doesn't really matter how complicated or not complicated. We follow the same process. Okay. All right, let's go ahead and take a look at the last example here. Consider the sequence. So this time I'm giving us a sequence and I want us to write the formula. So we're going back to the ideas from example 1. We want to make sure we know how to write the formula. Okay. All right. So recursive formula, I think, is usually the easiest one to start with because I just have to start with my first term. Now, because they don't tell me if it's a sub 0 or a sub 1, I can choose, okay? But whatever I put here will impact how I write the next part. So if I say a sub 1, that will tell me what I have to write for the next one, okay? So a sub 1 in this case is e to the 4th. Now, what's happening as I go from term to term to term? Well, I'm multiplying by another copy of e. So I had 4, but now I have 5, 6, 7. So each time I'm multiplying by e. That means we say a sub n is e times the previous term, where n has to be greater than or equal to 2. Because I already have a sub 1, so I have to start with a sub 2 in the formula. Okay. Or if you want to start with 0, you can say a sub 0 equals e to the 4th, and then a sub n equals e a to the n minus 1, where n is greater than or equal to 1. Okay, so if you want a sub 1 here, you need n is greater than or equal to 2. But if you have a sub 0, then you just need n is greater than or equal to 1. Okay, so either one of those is fine. However, you do need to have both parts here or both parts here in order to have the full formula. Meaning if you only give me this part, not enough information. If you only give me this part, still not enough information. I need to know where we're starting and how we're moving through the pattern. Okay. All right, let's take a look at this explicit formula here. Well, I think we really got this idea maybe that these powers go up by 1. Okay, so we could say that a sub n equals e to the 3 plus n if n is greater than or equal to 1, right? So let's see if that works. If I plug in 1 for n, I get e to the 4th. That's my first term. If I plug in 2 for n, I get e to the 5th, which is my second term. Okay, so this formula is totally fine. But some of us like to start with 0, and that's also fine. We would just say a sub n equals e to the 4 plus n, and n is greater than or equal to 0 if we wanted to start with 0. Okay, so oftentimes, depending on how you choose, you want to start with 0 or you want to start with 1. You want to start with 0 or do you want to start with 1, right? You have a little bit of flexibility there. Sometimes some textbooks or situations will say, let's start with 1, all right? But then other times we like to get those y-intercepts in there. So that's why we start with n greater than, or we start with n equal to 0, okay? So that's it for our intro to sequences and their notation, all right? Hope this has been helpful, and I will see you folks back here for 11.2.